All right, people who are joining this live stream, we are talking about the fundamental treatment of arrays in our language. And I guess that to me, one of the most obvious targets, well, let's take a look at the main issues here. One of the most obvious targets is repeated association keys, which is the row-oriented versus column-oriented question for things like data set. Right? I mean, and I think we've discussed before the concept of having a, what are we calling it? Association list. Is that correct? What have we called it? Hello? What have we called it?
I've never heard of this, so
Oh, for goodness sake. Okay, so I think Christopher has certainly heard of it, so maybe he can say something about it.
I mean,
I've
data
only heard
frame.
of the concept.
What's that?
It might be data frame.
No.
Oh.
No, that's not correct. We've had a specific discussion about this. I mean, basically the idea is the following, that, you know, just like it's row-oriented versus column-oriented, and all it's saying is, instead of, you know, right now we have a list of associations with identical heads, with identical key structures, right? And so the only point here is to have something where storage-wise, it just looks like, presumably, a bunch of, you know, key arrow list, but the true structure is the transpose of that. Am I making sense?
I think you have it inverted. Like, you want to store it as a sock, as key goes to list, but it needs to, like when you call select on it.
No, I know. That's exactly what I mean. It needs to walk and talk like a list of associations, but it needs to be stored as an association of lists. Right?
Yeah.
So, I mean, I think this is a thing that in concept, I believe to be not controversial. How it should be implemented, I'm not sure, but do people agree about this? I mean, for example, data set should routinely use things like this.
Is it a separate head, you know, a separate full form and head, or what is it?
Well, let's think about that. I mean, maybe what it is something which says, maybe it's something like this, association list of this, and that is, for purposes of list operations, that becomes, by the way, does anybody know where I'm storing this?
I actually am not sure.
Because we had a bunch of other discussions about arrays. So where are those? Do you know?
No.
Okay, well, there's an array operations, array processing. Here we go, under functional programming.
Okay.
Okay.
So by the way, I mean, for this array list or whatever it's called thing, would it be restricted to being one level deep, or could it work for deeper
I would
structures?
hope it could work for deeper structures. I mean, I would hope what it is a wrapper that says, you know, conceptually, it's like sparse array. And by the way, like a bunch of these other array types. Go ahead.
But isn't this just a data frame? I mean, what you're saying is that the key is basically the head for that column.
Yeah, exactly. I mean, yes,
but
for
although if it's deeper, then I'm not sure that's a data
no, of
frame.
course, then it generalizes that. But this is super important because you want to think of these keys as variables and things, you know, like that's
what explain that concept?
Okay, so in R and R and Python, this focuses on sort of data manipulation. Do you think of these variables, the keys, you think of them as variables, and you kind of start using them in various ways.
Right. And that's where they're called data frames.
I know.
And so the type is coherent in that list often, you know, for efficient storage. But of course, it doesn't have to, you know, it could be more flexible storage. But for compiler stuff, if the type is coherent in that column, it still generalizes matrix because the type can be different per column. You can have dates in one column and bits in another. And
Sure. Well, fine, whatever. I mean, okay, so, I mean, I don't particularly like the name data frame. I think by the time we've got data set, data structure, whatever, I think, you know, I'm not keen on that name.
Yeah, but the point is that there is actually a number of these structures that work like association list, but have different ways of
fine. But I mean, conceptually, what this is like sparse array. That is, sparse array keeps its data, and by the way, this is not it should interoperate with sparse array. It keeps its data in the way that it keeps its data, but as far as the outside world is concerned, it is a dense list. Am I making sense? So I mean, here, for example, if you did a select on this to extract a single record, so to speak, that select should kind of invisibly go ahead and get the association with a bunch of keys, if you understand what I'm saying, right? I mean, so in other words, this thing, so let's take a select here, okay, on an association list. What does select do on a sparse array? Did you understand my question? Can somebody answer that?
It might just densify it. I'm not sure.
Well, let's find out. Let's say
I don't think it works on sparse array.
Right, because select only takes one, right? Select doesn't have a level spec, right?
Well, I understand, but I'm saying here, if I say hash greater than 0 here, and I do that, what did I do here? What did I do wrong? Oops, I'm sorry, I did that in the wrong place. Okay, and that's not a sparse array.
Right, so it densified it.
Right, but so in this case here, we would almost certainly want this to return an association list.
Well, it depends on what your, well, I guess, yes, select, yeah, you would. But
No,
something like
absolutely.
map, it's more complicated because with map, maybe you're just adding 12 to one of the fields, in which case it should return an association list. Or maybe you're turning each of the constituent associations into, a string, and then that's not an association list anymore.
By the way, Sandra is commenting on our live stream. Please, not more data type heads. Says, I like the packed array approach where you basically never see it. And that is indeed something we should talk about. Whether there is a subterranean approach to the whole thing. Am I making sense?
Yeah, but I disagree. I mean, I think that the whole packed array business is like, it's really hard.
Okay, you're wrong. You're simply
on-
wrong. Packed arrays are one of the better, the fact that the implementation is not as perfect as it could be. It's just from a user point of view, you're just wrong.
I'm just saying that.
Well,
it's
it depends on what the user wants to do. If the
For
user,
99.5% of our users,
Stephen, if the user wants to write efficient code, it is so incredibly
okay.
easy.
For
to
99.5% of our
let me
users,
finish my
it's wrong.
sentence, Stephen. It is so easy to accidentally unpack without.
I'm well aware. I'm well aware. That's our mistake. But for 99.5% of our users, what we have is really a good solution.
Yeah, but
And,
Stephen,
and doing something where we expose it is stupid, and I'm not even going to discuss it.
But Stephen, if this is going to be something that is also a front end for like out of core data, if your data set is 1 terabyte and unpacking means bringing it all into memory.
Obviously, Carlo, you just got to be a little bit, use judgment, okay? Use judgment. It's not, something where you absolutely say, oh my gosh, we can't do this because you might unpack a 1 terabyte array. Of course, you can kill the idea by saying, if we were stupid, it would break, right? But the whole point is not to do that. Like, for example, what we're doing right now with dataset, where it's, do you want to store this in the notebook or not? There's, it requires some thought to see how to get those things to work. But clearly, and it requires some way of having some, I don't know, something like recursion limit, but it isn't that we have a thing right now for the maximum size of I forget what the variable is called, but that just defines the maximum size that it will automatically store locally, right? What is that called? Somebody knows. Itai probably knows. Do you know what I'm talking about?
I'm sorry, I missed something. Where what stores?
You mean the variable that
saying.
determines how big the maximum size before it'll ask you to store it in the notebook? Is that what you're talking about?
Yes.
$inline notebook storage limit?
Probably. But that's the type of thing. What really? What's it called?
Or is it dollar notebook? Maybe it's dollar
notebook inline storage unit limit. Okay. So
I mean, honestly, it seems like, I mean, it does seem like if you had some giant out of core thing, that's kind of a different use case from if you're, don't have a 1 terabyte out of core thing. I mean, maybe it could also be something where it does secretly work like with a packed array or something like that. But there could also be a top level explicit kind of lower level way of using it where it will never, densify, if you know what I mean, to use the sparse array analogy.
Right. Well,
and by the way, this is the same issue exists for sparse arrays, by the way. I mean, which is, you've got some 10 billion by 10 billion sparse array that's not actually very big, but if you're not careful, it might densify. But I don't know. I'm not sure how big an issue that is.
That's less of an impact. Sparse arrays, it's very much. You can have a massive sparse array.
No, but Christopher is saying that there's two things. There's the theory. There's the Carlo theory of it might blow up the world. And there's the reality of, does it actually bite anybody? Just like the famous x equals x plus 1 could blow up the world and cause nothing to work, but turns out it isn't an important thing. So
right, but I mean, to be fair, I mean, the operations that people are running on sparse arrays are much more, I mean, there's a much smaller set of operations for sparse arrays than there are for some more general data structure like this, which is why it might be worth having some, again, explicit representation.
Yeah.
No, I agree. I think
we do have a limit for sparse arrays, but it's not documented, and the default is to set it to infinity.
I see.
Okay, so there isn't really a limit.
Well, but what that tells you, Rob, what that tells you
high
is,
limit.
Okay, listen, what that tells you is, it's like a lot of these design things. In principle, it could blow you up. And there are some things where, in practice, it blows you up. But that's not one of them, apparently. Otherwise, we would have, like recursion limit or something like this, we would have, set a finite value for that. But look, if we were to do packed arrays all over again with current design thinking, we probably would have had a way to have an advisory wrapper, and we probably should think about this now, an advisory wrapper that says, I really want to make sure this is always packed. Do you see what I'm saying?
Right, and basically behaves exactly the same, except if it were ever to be unpacked, it will
complain.
It will complain, yeah.
Well, there's a message you can turn on.
I know, Tom, but that's not the point. The point is,
that's what Christopher said, isn't it?
No, it isn't. No, it's not about messages, right? It's about, you see the code, and with our modern design ideas, what we would have done is to have something where there's a thing called packed array, and perhaps in the early implementation of it, it wouldn't be subterranean, right? In the early implementation, it would be visible. But then as it gets supported more fully, it eventually can disappear and can become automatically done. But if you have a list which has an explicit packed array wrapper, then it is kind of giving notice to functions that this thing should stay packed. Does that make sense? I mean, does that make sense?
Well, staying packed at the cost of not working. So
that's correct. That's correct. That's correct, Tom. That's correct. That's what it means to have that there, right? It's So my point is, what we probably have done today is something where we say this is a packed array and it's got to stay packed, and that deals with it.
Hang on, can I ask? If you try and insert a string into it,
it will fail. It will just say error message failed.
Error message, and you get back $failed.
No, you don't get back $failed. You get back probably the unevaluated thing. I'm not sure.
Okay. Mm-hmm.
Right, but that deals with the objection, which again wasn't a very, of itai and so on. Oh my gosh, it unpacks and you didn't know it. Right. So in other words, if you say, I really, really want this code to be efficient, and I really want it to stay packed, well, then put a packed wrapper around it. And if and if it turns out that it unpacks, it bounces off and says, I'm not going to do this because it would cause me to unpack, and I'm not supposed to do that.
I mean, it seems like the fundamental issue is just that, there are sort of pro users who want to be able to control, for example, when their arrays are packed or not. But then if you sort of relegate packed arrays to being something where it can only be done explicitly, it'll never happen automatically.
Exactly.
And there's a vast sea of, amateur users who will just never take advantage of it.
Right. Exactly. And it's the same thing. So to me, the best of both worlds is you can put the explicit wrapper, or you can just, or you can have it happen automatically. And I think that will be the best situation with association list and related constructs. Now, I'm not sure that when it's a true out of core operation, it might be a different story. I'm not sure about that. I mean, in the case of something like video, we are making it appear, you don't really know that it's out of core, do you? Am I making sense?
Yep, no visual cues that says this is out of core.
Right. Now,
although video is always out of core, right?
Not necessarily, is it?
Wasn't there animation image? Isn't that in the notebook?
That one is in notebook. Video is always out of core. Audio has in core and out of core versions. And there is a visual cue that says which one is which.
Well, okay, so that means that if I send somebody a notebook with a video, it will break.
Right? Yes.
Now, I mean, we should be dealing with that somehow. How should we deal with that? I mean, at the very least, we probably should have the same indication for video, because, for example, if you were sending somebody a video, somebody a notebook, and it contains a video, then, one thing you could do is at least put that video in a cloud object that the person can access. Otherwise, you're just handing them a dead creature.
Right? That's a little dangerous, though, because the reason why the video isn't stored in the notebook most of the time is because it's huge, right?
Well, that's
or it
true.
Could be huge. And so putting it in a cloud object maybe is, similarly troubled.
Well, yeah, but I mean, the question is what actually happens? I mean, we haven't really had this issue yet because, well, I don't know, people are not yet routinely sending notebooks that have videos in them. But, what do we think is going to happen there?
I think that it's going to drive us to actually solve it. And I think that there are two solutions. One is an expanded notebook format that's more like an archive that has assets that you can bundle in. And the other one is that you move them to, like, say, our cloud and relink. So you have to you have to relink it basically to those.
I agree. I think those are both reasonable solutions. The cloud one being the more immediate one to be able to implement.
I agree.
But I mean, okay, so that should be the pattern also when we deal with large out of core data sets.
Exactly. So it's just, we already did it for audio. I thought it would be a big problem. We went down, these are the two solutions that we want, but it was just not enough incentive or eagerness to solve it.
So
video,
yeah,
this large data relocation.
Well, because we have this.
So
serious
audio is also
audio.
big. Audio is.
I know,
big.
but we have the serious option to save in the notebook.
This is not really practical. An hour
depends
of
on the
CD quality
size.
sound.
Obviously, but that's a different use case than the
No,
5
you
seconds.
frequently record like your whole damn meeting, right?
Yes, I know, Roger. I know.
Okay,
but
so that's
there's
an
a
hour.
different use case that is still interesting of the kind of research on sounds where it's a 5-second lump of sound.
Absolutely, sure.
Okay, so let's come back here to what we're basically talking about. I mean, I think, go ahead.
Yeah, there's one thing I wanted to add, which is other than the whole packing thing, if we're going wrappers, there should be another wrapper which is about sessions, basically. So if you're using normal heads for doing, I don't know, join and intersection and whatnot, and the data is sitting somewhere far, you might want to have a way to say, okay, group these things and do them all together before you bring me back the result.
Wait. What you're saying there is actually do operations out of core. Is that correct?
Yeah. Like
that's a different thing. I mean, so that's what, for example, your database framework does that. right? You're doing actual operations. You're doing database selects and things on the out of core database before it comes back in, right?
Yeah, sure. But what I'm saying is that if databases were to be one of the out of core backends for association list, then you wouldn't want to eagerly perform each, say, select or join or intersection or whatnot, wait for the result to come back and then do the other. Especially since maybe the intermediate results are too big to be brought back.
I know, but what you're saying is, which we know is of interest, right? Is, okay, you've got a data, some kind of lump of data. It's huge. It's stored in some out of core way. It's a file on some file system somewhere, right? You have something which is not where, it's like a snake eating something. It doesn't, maybe I don't really know the physiology of snakes well enough, but my impression is there's a lump that goes down the snake. It doesn't all, that's a bad analogy. Never mind. But you get what I'm saying, that it's kind of going and it is never, okay, in the basic operation of our system, the concept is you gulp the whole lump of data into memory and then you do operations on it. What this is about, and we've started to have a number of out of core kinds of operations, is something where you
sort of want to build up. You sort of want to, perform operations in a lazy way, and then
it's
when you
related
run
to
them
streaming.
in the end,
So,
right, and then when you actually run it, you run it by
data-
basically calling normal or something like that, and then that will actually perform the operations all at once. But then you presumably you've set up the operations so that what you're actually going to get back is small.
Well, that's what we've done with databases, right? The out of core databases. What we've done is a bunch of nounified names. I mean, let's remind ourselves how that works. What we did there, and I'm not completely certain it's the best pattern, but
you want to look for the entity class, yeah.
Right, but so what we're doing here.
I mean, that's not the right guy there.
There it is. Okay, so what this is things like, what we have is this kind of nounified thing, sorted entity class. Okay, which means I want this sorted, but I'm not actually going to do the sort right now. I am merely defining that this is talking about the sorted entity class. And then the thing that actually, when you call entity list or entity value or something like that, that's when the actual operation gets done. Right?
So by the way, it's just a design question. I mean, is there a particular reason why these have their own heads and you don't just call sort?
Yes. Okay, no, I'll tell you why. And I'm not sure it's the correct thing, right? The reason is sort just does what it does. Right, and what we would have to have here is an environment where that code wasn't evaluated, because as soon as you actually have sort there, well, I mean, so the alternative would be that sort is.
But I mean, you'd have some sort of, I don't know. I mean, I'd imagine you could do a similar thing with sort, though, couldn't you? Where you have some sort of, database object, you call sort on it, and it returns some, processed database object, which that sort has been called on it. And then you can, build this up, and then you can eventually normal it or something.
Exactly.
But that's the core of the notebook that we sent out. Like, there is a number, like, call it association list or data frame. There's a number of operations that go from association list to another association list, sort, select, and whatnot. There's this basic algebra of things you can do that stay within.
But Christopher is making a different point. The point he's making is this design, where we build this up implicitly, may not be the right design. The alternative design, which we didn't consider adequately for a number of reasons, which I don't think were very good reasons, is to have some kind of database object thing and to basically say, special case for sort. It doesn't do what sort normally does on a single element, which apparently is just to return that element. Surprises me a little bit, but anyway, instead it does some operation. And so then, exception for select, for example, if it is applied to a database object, it doesn't do the generic thing that select
Why
does.
does it have to be a database object? Why can't we have something that works like that and is just an association list? I mean, the operations that you can do on something like that are the same. Because
No. But I'm making a different point. The whole point here is that you are not getting back the reason we have sorted entity class is because we don't want sort to apply itself to some symbolic representation of a database and just make a big mess. Instead, we want something that represents the operation of doing sorting, but we only want to actualize that operation at the end.
Yeah,
right?
I have to say that I've been solving all these problems with streaming, and basically the last 10 or 15 minutes of discussion, all these ideas have been already incorporated into that. So I could
that's good.
possibly expose it to people. So because I've been solving all these problems already.
Okay, but let's just enumerate what we're talking about. Just to be clear, the alternative design here would still be to have some kind of database object or database query result object.
Who
that
solved
is
it with streaming? Who was that?
That's Leonid.
Leonid.
Okay.
So let's just go back through this for a second, okay? So approach, basically this is approaches to lazy / out of core operations. Okay, so one approach is, an explicit head that has random stuff represent, inside it. Okay, what do I mean by that? I mean that, and maybe there's an example of this with video. I suspect video is an example of this. In other words, video, well, you guys tell me, if I do an operation like I binarize a video or something, what's happening is, what could be happening? I don't know whether video operations are always eager or whether they can be lazy. Can they be lazy?
Currently, they're all eager, but we have discussed video filter graph ideas so that we can store a series of operations in a video object.
Actually, I'll give you a case where it's not where it's lazy, which is a trimmed video, what do you call it? Something where you've time selected the video. You're not doing that explicitly, are you?
That one is not in yet, but we have discussed it as a time selection option. We do have a track selection option where that's lazy.
Okay. Well, fine. All right. So track selection is then an example of what I'm talking about here. So what that means is, what that means is that the thing you see is a video, and there are aspects of it that if you were to try and get its bits out, there would be some operation which has been held up that has to be done before you do that. Okay, so that's one example. And explicit has random stuff inside it where what's inside is modified, but this is your filter graph kind of is modified by the eager operations applied to it. Does everybody understand what I mean by this? Maybe there's a better way to say it. People understand what I mean here. So this is like saying sort of, I don't know. Go ahead.
I mean, it's as if, you probably wouldn't want to implement it like this, but maybe you would. It's as if sort just returned unevaluated, and you could call all these functions, they're all unevaluated. But then when you call normal or take, or I don't know, some special function like that, it'll actually run them all at once.
No, because that's the entity approach, that you are building up something symbolic that's nested heads. Here, the idea is that
that's not right, Carlo. That's not right. The whole point is here is.
I think Carlo's right.
It goes inside.
I think that's the same thing. I think these are kind of the same. It's just a matter of whether you're actually building it up as unevaluated heads, or whether you are evaluating.
So this is a separate choice.
Something slightly different.
Okay, an explicit head that has random stuff inside, where all you see is the head. Okay.
Yeah, sure. Yeah. So you don't build it up unevaluated. It goes inside. It's different.
Right. But okay. So then the second case is the different, distinct case is.
Why does this have to be database specific?
It's nothing to do with databases. I'm just using that as an example.
No, what I'm saying, why do we need different heads for different backends? This is
I know.
I think that's the point, is that we're talking about why is it, filtered entity class instead of select. Right.
You build up a symbolic structure of unevaluated operations.
But again, I mean, the only potential issue or one of the potential issues with unevaluated operations is that having select sit unevaluated might be a bit weird.
No,
right?
I know, but we can't do that. We can't do that unless we have, so there are two approaches to that. Number one would be some kind of weird inactivated select, okay, which I don't like very much. Inactive select, a blah, I don't like that. And the alternative would be the selected entity class thing where it's a different, where it's a what is it called anyway?
Well, and then the third alternative, which I think
it's filtered,
is actually how like that. Well, or it's just that you have that it just modify, it just goes inside of the entity class. At the head of the thing that gets returned is still say entity class,
but it has some
arguments in it.
That's this case here.
Well, no, because that has head filtered entity class. I'm just saying, this is something where it does
no. This first case here, this first case, look, there are two cases.
Okay, yes,
either, to be clear, either we say sort of database object and blah, 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 or the alternative to that is to say sorted entity class of an entity that, of something which is an entity class or whatever it is, which stays the same, where you don't mess with that entity class thing, where that's immutable, so to speak, and it's the wrapper outside that, well, shouldn't say immutable, that's unchanged, and it's the wrapper outside that stores the operations. You see what I'm saying?
Sure.
So I think these are two cases, and honestly, I'm not sure we picked the right one for this. But now let's look at the next case, which is that the next case is invisible laziness, which we don't have yet, to my knowledge. Which is more
so by
like
invisible, you mean okay. So you mean like you run the operation on it, and it secretly doesn't actually run it. But if you, for example, displayed it, if you printed it to your notebook, then it would actually run it.
Right. Only visible on serialization or something. Only visible on sort of human interaction or serialization.
Oh, streaming does have all of that.
Okay, I want to hear. Let's hear about streaming, Leonid. Do you want to show something, or do you want?
Well, I wasn't actually prepared to demo this today. I can probably just today I could just mention a few ideas behind which on which it is based.
Okay.
Really. So basically, there is a single structure called lazy list, which is exactly this invisible structure. Whenever you apply some operation to it, it stores inside the information that this operation has to be applied. And it also has a notion of chunking built in. So it automatically kind of distributes that operation to which operations have to be applied to individual chunks. Then whenever you apply next operations, whenever you chain them, it basically translates that into chaining operations on individual chunks. And it does this in such a way that you can still be efficient, because chunks are large enough that you can use vectorized approach on individual chunks. And then you kind of factorize the whole problem into a problem of operating chunks and the problem of what happens inside each chunk.
Let me see if I can summarize a couple of things there. Okay, so one point is, it is in principle the case, even with this kind of approach, the symbolic structure of unevaluated operations, that you could have a program transformation step in which you notice that if you say sorted entity class of sorted entity class, it's like you don't need both of those. You can optimize one of them away, right?
Yes.
So there's a set of transformations, and for your purposes, to maintain chunk integrity, that is, there are things which are local operations within chunks, there are things which have to go between chunks, and presumably you have to know, oh, this is a sequence of operations that are all local to chunks. We can put them all together, versus another thing where we have to do global synchronization before we can proceed.
Yes, in fact, it's even much simpler than that, because what I've been doing was basically that you mostly either you are able to translate for certain operations the operation on overall structure to operations on chunks, and then each chunk accumulates its own individual queue of operations that have to be applied.
Yes.
Or if it's non-local, like for instance for sorting, then you have to basically invent an algorithm that would still utilize vectorization on chunking, but it will still be chunked in nature. But it can't be fully lazy. That's the problem. Like with sorting, for instance, it's actually hard to invent a fully lazy sorting algorithm.
Sure.
And then there are, yeah.
Let's just summarize for a second, because I mean, this is very related to parallel distributed computation type questions, right? And there are things where, I mean, in our modern view, which I'm sorry to impose on people about reference frames, and you know, this relates to the whole multi-computation initiative, which some of you have heard a bunch about thinking about kind of this question of when do you have to. It all relates to what counts as now across this large data structure. Because you can have basically simultaneity surfaces across this data structure, which might, for example, what you're saying is, if the thing is purely local, you can pick any simultaneity surface, it's okay. And so long as eventually the things get done, it's going to work. But if you have something where you have to currently synchronize, you need, you know, a different simultaneity surface. And,
well,
you know, go ahead.
Yeah, it's certainly related, but I think the situation that I was considering was much simpler because most operations were sort of referential transparent. So, you know, if you could instead, you didn't even have to think that much about synchronization. But obviously what you're saying is correct as soon as we start to parallelize things, right? So yes. In fact, I was actually designing streaming to be kind of an easy way to parallelize eventually, because indeed, well, obviously, if you start considering mutable operations, that will become really hard. But for operations that we were considering for streaming, which were mostly, you know, immutable operations such as map or fold or split or transpose or things like that.
Yeah, right.
So for those, it became possible to actually factorize all of them into what you do with chunks versus what you do with individual chunk. And apparently, they were kind of immutable in the sense that you could process chunks in principle in any order you want.
Multiple questions here, okay? Sure. So first point is, from the user's point of view, is there a thing that they see called lazy list?
Well, I think it should be, although in the past, we were thinking that this will be a strictly supporting structure for dataset, but that turned out not to be a good idea because
but we have the exact same issues about packed array versus other things. You know, should one see the fact that it's a lazy list? I mean, I would like to point out that, for example, graph is an example where I have no idea what its internal data structure is, and I believe that it switches around that data structure depending on what's happening. Is that a true statement, Roger, or other people?
Yes.
Okay, so that's a big success because I don't, you know, I use graphs a ton and I haven't a clue what it's underlying.
Geometry uses even more data structures. That's even more data structure rich.
Although some of those are visible at the top level, but maybe not all of them.
Yeah, but some that you think are visible actually have a big iceberg underneath them that you didn't know about.
Right. Well, so,
well, I mean, my opinion based on the experience with streaming is that in this particular case, for the chunk list, exposing it would be correct thing to do because it's too different from normal list, both in terms of how it operates and in terms of what API it supports. And our attempt to eventually support the entire list API for lazy list was kind of doomed from the start, which is why I think that exposing it would be a right thing to do in this particular case.
Oh, yeah, but what you're arguing for is what I was saying earlier, which is, you know, at the beginning, you expose it because it only supports a limited set of operations. As you get more operations supported, it can potentially be more automated and integrated. I mean, that's a possible approach.
Yeah, the only thing is I think, I'm not sure this is a real distinction, but I mean, with something like lazy list, okay, with something like packed array, if you can pack it, it's always going to be faster, right? It's always going to be faster, more memory efficient, et cetera.
Yeah.
But with something like lazy list, my impression is that, there are cases when you'll put it in a lazy list and everything will be much slower, less memory efficient, etc. And so I don't know, it seems like a more dangerous thing to do automatically or do invisibly.
Yeah.
Actually, packed arrays, it's not always extracting like a row from a matrix is faster if they're stored individually. Than
Right, but I want to just say that in modern times, graphs and geometry are a great big success story for subterranean data structure, juggling. And we should learn from that.
Stephen, I think one thing we could do is like to follow a similar approach to the compiler, which is
streaming with data set. Sorry, Carl, can I?
Yeah.
Hello?
I mean, just let me finish.
Okay.
We could expose the data structures as something like data structure, but that works out of core. And so if somebody wants to do really low level stuff, they can do it with that. But then there would be a number of data structures that are exposed through that, which have a similar structure, which is like the association list one, that could all be subsumed in the same interface, a data set-like interface, where you can use normally sort, and that's gobbled in, and then you could do normal. And
Look, I think that the general point, as I was saying before, is were we to do packed array today, we would have an explicit wrapper that you could use. Right? That indicates, and I don't know, in the case of geometry, maybe we have a similar situation where there are explicit wrappers that you can use, but there is an automatic process where you never have to know about them. Right? I believe that's the best of both worlds, and I believe that's what we should aim for.
That's kind of how we design it. I mean, we bring things to the surface when we think that the use case is broad enough.
Right.
There cannot be sort of a graph is simpler, it's finite graphs. If we had to deal with infinite graphs, we would have other kinds of things. But so it can all be represented, just more or less efficient. And I believe that what we're talking about in this meeting is finite stuff. It's just big. So it can all be represented, just more or less efficient.
Well, sometimes
geometry is harder.
Although there might be things that are big to the extent they're effectively infinite, right? Like if you have a 1 terabyte out of core thing, it's effectively infinite. If you actually try and load it all, you're just as doomed as if you tried to load an infinite thing.
Actually, streaming does support infinite lists just as well as finite. So
that's what Christopher is basically saying. If it's a petabyte in size, it might as well be infinite.
Yeah. So we're getting states in between, but geometry has actually uncomputable things, actually unrepresentable things. Sorry, that's the nature of the field. A mesh region cannot represent everything exactly.
I see.
Because not everything is piecewise linear in the world.
Sure. Okay, but that's a different issue. But my point,
in this case, we could define as a backend to this something that is like a generator in that thing that was in Roman's book like 25 years ago. Like it's a function that is generating the things, or it's an external API, maybe. One of those pipes of data, like the stock market.
So just a second. So let's say, data sources here. Okay. So one is, explicit data, e.g. in a file. Another is a generator. That's what we have for things like video generators and so on. Although I haven't liked very much, a function-based generator, basically.
I don't think that's a good example.
Okay, but fine. But you get the point here. And another is external streaming data, where you don't even know, where there's no way to know what's coming, and it's so. Someone's mentioning that Roman gave a talk about array iterators. Roman, what was that about?
Yes, I mean, the iterator is a generalization of the lazy lists where essentially the only operation you allow is to produce the next element. And so they behave just like lazy lists, but they can have more efficient generators like a compiled. Think of generate all binary trees. It's non-trivial to come up with a next binary tree algorithm. But once you have that, if you then want to run a a select operation on binary trees, you can run that operation on trees that you would never fit in memory at the same time, but it's still efficient.
Right. So this is the iterator, just the kind of just give me the next element.
Yes.
And
there's a lot of things that are sort of filters on top of that, like set.
Yes.
How do you define a set, for instance, like with a condition?
And I mean, it goes into that category of things that have their own head and that may internally accumulate whole operations. Like when you do a map, you don't just do it when you call it, you do it as you need the next element. So this is a natural way of accumulating processing inside, and you don't need to know about it.
Right, but so that's basically this example. This is,
yes.
It's. I mean, we can call it. It's. What are we going to say? It's all in its head. That's not quite the right. That's not quite the right characterization, because it actually isn't in the head. Actually, it's in the expression.
By the way, Stephen, I don't know if you remember, but a few months ago, I told you that I had an experimental version of the database stuff that used this approach by using compiler tech to construct a class object.
Okay, that's interesting.
So I don't know.
Well, that's
one important property of this approach is that it's surprisingly easy to overload essentially all our list processing operations to just work with these iterators or lazy lists instead.
Okay.
And so you do have a separate head, but you can still use select, map, first, last, reverse, and so on.
Reverse.
One thing maybe to mention, though,
how does reverse work? I mean,
well, it obviously only works on finite iterators and last, but so it is naturally a partial operation. I mean, an infinite list will not have a last element, and if you do a select, you may never find another element where the condition is true. So these are all operations that may not terminate, but that's just the nature of things.
Sure.
Right, and one note maybe is, I mean, I don't know if this is exactly, if I don't know exactly how this works, but at least when I've done similar things, the issue is usually that if you don't have some sort of chunking, some things do get very slow, but that might be okay in some cases.
But so let's go ahead. I wanted to come back to Leonid and hear more about his laziness.
Yeah. So I want to make a few comments. First of all, the chunking idea was specifically to make things fast. So I realized that it's okay for large data to sacrifice laziness on level of individual elements, but what you get back from that is high speed. So that's why there was this idea of chunking. So
question, when you are applying chunking, and perhaps you're doing it in parallel and so on, you had external code, if I remember correctly, that was built to do certain operations away from the kernel, out of core. Is that correct?
Well, streaming itself usually operated by loading certain portions in core and then applying things in core. But one thing I want to mention is that the abstraction of lazy list can accommodate also operations which are done on chunks which live elsewhere. So abstraction itself that is not restricting us to in-core operations. It's just more that implementation that I was using was the one for in-core operations, in sense of how it divides things into chunks. But I wanted to make a few more comments for what was just said before or previously, just now. One thing was that, incidentally, if you look at data sources, then the streaming was designed so that all of these different versions actually worked. So I have a constructor for lazy list for all of these things, for explicit files, for function-based generator, and for basically an iterator. I had internal iterators which basically streaming lazy list could consume. So one example I had was a file, a large file. You want to get from it, for instance, first 10,000 elements, and it will only read file as much as necessary plus a little bit extra, so that those elements, you get those elements. So basically you feed an iterator which reads the file, and lazy list will only read as much from that iterator as you need to read the first whatever number of elements you actually want. So yeah, that was about it.
So look, to me, there are two basics, maybe three basic stories here. Okay, claim. Story number one, templated array structures. That means if we look at all of these kinds of things, those are array structures where there is an underlying, storing numbers in memory locations type thing, or whatever it is, and maybe strings, I don't know, that's a separate issue. But then there is something externally templated about it. That is, to the outside world, this should look as if it's a list of associations where that element is referenced by this sequence of keys and blah, 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 right? But to the inside world, it's just this. In other words, it needs a transducer of some kind where, if you think about it in terms of not category theory, but I don't know, something, what's happening is
a microphone is a transducer, right?
Well, yes, but what I mean by that is a two-way operation, right? What's happening is you have this templated array structure. It is a quantity array of associations of blah, blah, blah. It has some wrapping structure that says everything is in meters per second and it's a bunch of keyed associations. But internally, all you see, and it reminds one a little bit of the neural net case, because again, it's basically grinding everything down with a net encoder to the point where it's just an array of numbers. Is this making sense? So in other words, we're going from, what we've got is external structured data goes to, through some kind of, goes to internal pure array of numbers, and then externally, and then it comes back externally to be external structured data again. It's making sense. So in other words, let's say that you said, I want to get the maximum value for this whole thing, right? I've got the external structured data, but now the maximum is really being applied to this internal raw list of numbers. But then when it comes back out again, it gets the meters per second wrapped around it again, after the max operation has been done purely on the internal array of numbers. Did that make sense?
Yeah, what you're talking about is just encapsulation idea, right?
I guess.
Basically.
I guess.
Well, but is this supposed to be something visible? Like, I mean, quantity array is visible right now, but are you talking about making this as well?
I'm talking about generalizing this idea that we've got for all these different array types to be something more like this. That is, there's a template for what's happening inside, then there's an inside, and then when, if we talk about...
So
the only thing is,
actually, we built that. And we're about to roll it out in 13.1. So, and actually those things that you see there, quantity array, sparse array,
quantity array and symmetrized array, right? I mean, that's grouping is wrong.
It's a project we call structured array. It was intended for something else, but what it did was to make the operations work. And so what it does is to store, if it has more efficient ways of working on that particular structure, let's say it's a Vandermonde matrix or something like that, which the determinant of such a matrix is trivial.
Right.
If it knows something better, it uses that. If not, it converts to either all the way up to sort of a general thing, or it's some other structure.
But here's a way to think about this. Let's say we have a function f, and it's being applied to this templated array structure, okay? Then what has to happen is there's a transformation, a change of coordinates for f effectively, that because to get to the raw array of numbers, f must be transformed. Like, for example, let's say, I don't know what's a good example of that, but you get what I'm saying, that is that the thing you apply to whatever, a sparse array will be a good example. Let's take the max of a sparse array or something. Then let's say that it has to, the pure max operation is doing something different because it is being applied to the sparse array values, not being applied to the dense list of numbers. So as it passes through this structuring process, the external operation has to change its character. Does that make sense? And then it has to go backwards
Actually,
on the way out.
Steven, it's exactly, I just want to give an example. In streaming, that's exactly what's happening, because if you pass select on it, it is getting translated into some modified functions applied to individual chunks, which are based on select, but they are not real pure select.
That's exactly else. Right. But so this is a general pattern of there is a templated array structure, which could also be a chunked out of core streaming, whatever it is, structure. But it is a wrapper that defines a structure that is the external exposure of the structure. I mean, it reminds me a little bit of how, for example, data drop works. In a data bin, again, it has a sort of a template structure. Now, this also is reminiscent of types, I would assume. Because again, types, well,
there is a covariant and a contravariant transformation.
Exactly.
I mean, yeah. But yes. I think one thing that is really important here is that I mean, the thing you have there on top with the association list is very, because dataset could have been this, but it just wants to be arbitrarily nested in something like that, which is something that we really can't do for everything in full generality. Well, there is a very large number of operations that you can do on association list and stay within association list, which can be done efficiently even on out-of-core data.
Right, but so the first concept, which it sounds like Roger has worked, multiple people have worked on this, is this notion of a templated, I don't know whether it's necessarily an array structure, but let's call it an array structure for now. Something where it gets wrapper information, quantities, keys, those kind, what kind of wrappers, what kind of wrappering can there be?
Actually, sorry, as a quick question, I mean, for structured arrays, I mean, is there some interface where every type of structured array provides these 10 functions from which, max and select and so on can be implemented? Or is it more like, you give a certain set of functions that have special implementations, and if there is no special implementation, then you just fall back on you densify.
It's the latter, Christopher. So there's a specific way of saying how, say, I want to implement max, and you can do that for your particular structure. And if you don't do that, then it falls back on converting to normal or sparse array or whatever.
Okay, makes sense.
Okay, so just what kind of wrappering can there be? There's very surface level wrappering, units, association keys. Those are essentially metadata. And there's also compression of the array, like a symmetric array where you only store half the elements or whatever. Are there other kinds of wrappering? Yeah.
I think
arguably,
I think what we discovered,
association list is also a form of wrappering in the same way that quantity array is.
No, that's what I'm saying. Association keys is one of the things.
But the frameworks that we implement stretch differently far. I think what we learned with the structured array, which was meant to be rolled out some time ago, and it did, but in more creative ways than we had anticipated, with Jose having other needs, like for symmetrized array or quantity array, we hadn't anticipated those use cases. And we keep seeing more of those that it wasn't really designed for, but it actually it's a template that can be used for that.
Okay, so I'm going to make a different point here. I think there's another thing, which is data structure transformation. So for example, it could be the case that the underlying sort of naked array is actually a linked list. That's the thing we're not completely discussing here. That's similar to compression of the array by being sparse or something.
Sure. I mean, all the data structures support an iterator, and that means you don't have to write it. That gives a great degree of abstraction. So like you can have like map or scan or something works over the data structures, but you don't have to write special code for linked list or,
Well, I know, but what we're doing right now with data structures, look, what we did there was a very conscious thing. We're not allowing you to just say part of a data structure. We're having some explicit property of a data structure, which is its part, whatever it is, right? And we did that because we knew that we're not globally supporting all operations on all data structures, right? So we don't want to give the wrong expectations.
Right.
But what this is saying is, with the appropriate wrappering, it could be the case that, you know, the wrapper automatically essentially unpacks if the operation you're trying to do isn't known how to do with the data structure, directly with the data structure.
I mean, the only thing is, I think, this is maybe a bit of an implementation thing, but I think that we probably want to do a little bit more than just, you know, if the function you're trying to apply is on the list, then it has an implementation, and otherwise it fails. Because the thing is, it's that, I mean, the issue is that there's probably, I don't know, between 500 and 1,000 functions that basically operate on lists or arrays in the language, right? And if you tried to, you know, implement every one of those, you know, replace part, etc., you know, for every single type of array individually, I think that would be pretty painful.
Yeah.
So I mean, I think that the thing that you'd love to do, but which I think doesn't quite work, is that you have some interface where you say there are these, you know, 15 functions, you define these 15 functions, and now, you know, intersection has a special implementation that can work just using these 15 interface functions and so on. I don't think that works fully in general, because there are things like, you know, I think symmetrized array is sufficiently different from quantity array that that set of 15 functions that you can expose is like totally different. But I think that there are probably at least groups where you can say things like, you know, the quantity array, geoposition array, you know, maybe the association list, maybe that's one group and they can have their own interface, and that can be implemented for all these functions. And then maybe, you know, there are other sets of you know, sparse array and symmetrized array and so on. Maybe they can have a different interface or something like that. I don't know. But it seems like it's worth having some groupings.
Right, but there's also coercion chains where you say, I can't do this on a doubly linked list, but I can do it on something else. And there's a fairly straightforward coercion to the thing on which you can do it. Is that related to what you were saying or not?
Yeah, and it's also a way to think about importing in a way. So, like, if you think about it, importing from an external file is a coercion operation, or converting between two different out of core formats.
Sure. Well, right. I mean, it's like you could store it. Look, it's like with video. With video, you are leaving it in whatever weird codec it's in, and you're doing operations on that. Similarly, with a file, you could leave it in its CSV format because it's not worth taking that petabyte of data and converting it to something with explicit, you know, with tabs instead of commas or something. Am I making sense? And so, in other words, that's a case where you're okay. So that's an interesting case, because this is where, you know, they're different cases, right? Either you have control, either you have control over the internal array, or it's something you want to treat externally, e.g. it's a CSV, e.g. an external CSV file. Did that make any sense? So, I mean, in one case, it's like you've got encapsulation wrappering that you want to apply to an otherwise pure list of numbers. In another case, the actual thing inside is something that's kind of from the jungle, you know, an external CSV file, and then you're going to have to do a version of this. You're going to have to do another level of function that unpacks, you know, as the chunker comes through and wants to see that part of the CSV file, you're going to have to convert it into something that the operations that get done on chunks can recognize. Did that make sense?
Yeah, exactly. And I think that what Christopher was saying is very important. Like, if we had something which is a little bit like data structure, but I guess can't really be data structure itself for these kind of things, then we could design some kind of a smallish API of this, which include transformations from one format to the other, from one data structure to the other, basically. Mm-hmm. And on top of which all of these top level things like sort get implemented.
Right. We are running out of time here.
Steven, I wanted to suggest one thing for the next meeting. I could prepare like 15-20 minutes brief discussion of streaming where I could expose what I learned on that through, you know, very brief examples.
That's fine. That sounds good. Look,
Okay.
I think we are developing a direction here. I think we haven't addressed issues like missings and all that kind of thing, but we are, I suspect that, I have an idea about how that might work. I think this is a useful meeting. I think it has many stakeholders, some people who have been here who don't think they're needed for the next iteration of this meeting should drop out.
Okay.
We haven't discussed, let's just check for a second, people who are here whose areas we haven't discussed. We haven't discussed out-of-core machine learning, which we probably should discuss. I don't know whether that's going to be a very different discussion from what we've had here or for something quite similar.
And Julia should be there for that.
Okay.
Okay. I'm not sure, things like, numeric array and byte array, well, particularly byte array, I suspect is a somewhat different story that I claim is not as closely related to this stuff as other things. Perhaps that's essentially type or type transformation, right? So that's a case where, gosh, what the heck is that? That's something where you're storing can anybody comment on that? Is byte array related to all the stuff we're talking about or not?
Type transformation, I think, is more of the numeric array. Byte array is really just for transfer, not transformation.
Yeah.
Right. We've never developed a lot of operations on byte array. We've never found a need for them.
Right.
Well, we have different operations, right? We have string to byte array to string.
Right, but that's a transport. I mean, it's basically being used as a transport layer.
Right.
It's not being used as a thing on which you do computations.
Correct.
I mean, we could have searches on byte arrays, but we don't particularly.
Does part work on byte arrays?
I think it does, yes.
But
I think it's
But
one
I
of the
don't
only
think
things
it
that
has.
works.
Say that again?
Can you not a byte array?
Can you do what?
Not.
Well, you can do it with bit not, I think.
I'm not sure if vectorizes over it. Very few operations work on byte array.
Right,
Correct.
but it's still been very useful as a transport medium, which is what it was originally for. So it may not be it may not be related to other things we're talking about here. All right, I would like to, I got to go, but
Should we get back together next week?
please do. Yeah, I think this is useful. I think we can, in probably 2 or 3 more of these meetings, we can grind out something which I think will be a credible design for this. It's going to take probably much of this group to go through that. Okay.
And thanks.
All right. Thanks a lot. Thanks to folks on our live stream too. Okay. Bye for now.